Hi guys, we're going to be looking at three problems today. Okay, the first one says give the domain and range for the relationships shown in the graph. Okay, the first thing you want to do is write the ordered pairs for something like this. Okay. So if I look at these points, let's go and start jotting them down. This is negative 2, 2. Negative 1, 1. 0, 0. 1, negative 1. 2, negative 2. And 3, negative 3. Okay. So again, they want the domain and range, so let's give it to them. Okay. The domain. Okay, we'll just use the letter D. The range, the letter R. Okay. We'll use this brace here, and basically I'm going to insert all these individual values. So negative 2, negative 1. Right. Here's the other x value, right? The domain is the x values. 0, 1, 2, and 3. The range would be my y values, so I'll just insert these values. Okay, 2, 1, 0, negative 1, negative 2, and negative 3. Okay. Go and move on here. Now, and let me go back this way. Okay, so a special note, these are your x values. Okay, and these are your y values. Okay, I guess while we're on the topic, we can call this also your input and your output. Okay. Next, you're going to be looking at data like this, okay, shoe prices and statements like this. Ultimately, you'll be asked to determine whether each relation is a function. So let's talk about how we operate here. Okay, here's a nice little setup. Okay, what I recommend you do is identify the domain and the range. Okay, once you have the domain, right? In this case, we'd be looking at 7, 8, 9. Okay, and next we need to identify the range. 35. Now notice how it's written 3 times the same value, so I'm not going to repeat it. Okay. Now what I'm going to do here, okay, is I'm going to make a mapping, right? The 7 gets mapped to him, the 8 gets mapped to him, and the 9 gets mapped to him. Okay. Now if you look at this, you have to ask yourself, is this a function or not? So the answer here is that it is, okay, because of the following, okay, because you can declare, among other things, that you have a function, and among other definitions, here's maybe one of the easier ones, okay, every x has exactly 1 y. Okay, I'm not sure if that's confusing, so let me spell out actually the 1 y. Exactly 1 y. Okay, so hey, this x has this 1 y, this 1 y, 1 y. Okay, let's take a look at this one. From the number of items in a grocery cart to the total cost of the items in the cart. Okay, so let's go ahead and, because of spacing, I'll just quantify, let's say, the number of items in a grocery cart to the total cost. Okay, so the domain is the number of items in a grocery cart. Okay, so let's go ahead and pick, I don't know, somebody has 2 items in the grocery cart, and somebody has let's say two small items, right? Somebody's paying $5. Two larger items, they're paying $20. Okay, so in this case, right, we have this mapping. Okay, for two items, someone paid 5. For two items, somebody else paid 20. Now we can see that this x, right, is being assigned two y values, and therefore this is not a function. Okay, so in summary, on this case, we have a function and we have not a function. And lastly, use the vertical line test to determine whether each relation is a function. Here is one of the easiest things to do. Many of you guys have seen this. So let's get a vertical line. Okay. If at any point this graph touches this line twice, it's not a function. Okay. Here we notice that at this point and at this point it's touching twice, so we can declare this a function and this not a function using the vertical line test. Thank you.